In this video, we'll take a look at how to calculate probabilities and areas for problems involving the normal distribution. Okay, so if you have a data set that's normally distributed for some arbitrary mean and standard deviation, typically we'll be working with what's called a non-standard normal distribution. So it has the same general bell curve shape. The center would be at the mean, and the spread is described by the standard deviation. So we've already seen that with the empirical rule, if it's specifically exactly at one standard deviation to the left and to the right, that's 68%. If it's exactly two standard deviations to the left and to the right, that's 95%. And if it's exactly three standard deviations to the left and to the right, that's exactly 99.7%. However, we want to calculate values and probabilities for any position, for any x value. And so that's what we're going to discuss here. If you convert everything in the form of z-scores, then that's working with the standard normal distribution, where the mean will be exactly at 0, the standard deviation is exactly 1, and the total area of the normal distribution is equal to 1. However, because the graphing calculator allows us to calculate with any mean and any standard deviation, we'll just stick with the non-standard normal distribution and not worry too much about z-scores. I mean, if you need to use a table like this to look up the areas, then you would need to convert to z-scores. But again, we're going to be using the graphing calculator to do the calculations, so we won't need a lookup table like this. Typically, for a non-standard normal distribution, this is going to be the notation that we're going to use to describe the mean and the standard deviation. Okay, so let's take a look at how we do the calculations. Right, so on the next page here, at the top, 2 bullet points are the 2 operations, so the 2 commands on the calculator that we'll be using to do our calculations. So it depends on, in a given problem, if we're trying to calculate areas and probabilities, or if we're trying to calculate x values. So if you're calculating probabilities, then the operation is called normalcdf on the calculator. It's in the distribution menu, right? So for normal distribution, right? So it's in blue above this button here. So you press second, and then distribution, and then it gives you a bunch of options. Again, the one we want here is normalcdf, right? So be careful. There's two operations here that look very similar. One's normalpdf and the other is normalcdf. The one we want is the normalcdf, right? So for cumulative distribution function. So that's the normalcdf, and depending on which version of the calculator you have, you might have a screen like this, or you might have to enter in the command like this by putting in the parameters lower, upper, mean, and standard deviation separated by commas. So my calculator is like this, so I would just enter the 4 parameters into the screen. So one thing to be careful is that we're going to be calculating probabilities when the shaded region could have different positions, like looking at the 3 diagrams here. So if it's shaded all the way to the left here, I mean, essentially the graph goes to negative infinity and positive infinity, but the calculator doesn't understand that, right? So we'll be using the number negative. So this is in scientific notation, right? So this capital E here. So this E is this EE button on the calculator. So you would press, so if I wanted to enter in -1 E99, right? So that'll be -1, and then again, scientific notation is this EE key here. So second E, and then it should look like this on the screen, and then 99, right? So that's what we use to represent negative infinity, and for positive infinity, if for some reason in a problem, let's just put one here for now temporarily. If the diagram, the shaded region goes all the way to the right here, and we want to represent positive infinity, the number would be +1 E99. Again, how we use the lower and the upper, so they stand for lower bound and upper bound, right? So it depends on how we represent the shaded region here. Okay, the mean and standard deviation would be just the given values in the problem. So that's when we calculate probabilities. If we want to calculate areas, the command would be the invNorm command. So again, it's in the distribution menu. So distribution, the third option is the invNorm. Again, depending on your calculator, it might show a screen like this, or you might have to enter the command like this with the three parameters separated by commas. So one thing to be careful about the invNorm command is that it only calculates when the shaded area is to the left, right? So like in a picture like this. However, in the case where we need to calculate when the shaded region is to the right, like B and C here, we need to do a modification because again, this area is only for the left area, right? So what we would do is we take the complement by switching the shaded region, and because the total area is equal to 1, we can always calculate the complement by doing 1 minus the area, right? So the left area is equal to 1 minus the right area, and the right area is 1 minus the left area. Okay, so that's how we would apply the invNorm command, again depending on whether the shading is like this or the shading is like this. Okay, so with that in mind, let's practice with some calculations, right? So in example 1, we're given these normal distributions where the mean is 100 and the standard deviation is 15, right? So in notation, we would write it like this: the normal distribution with mean 100, standard deviation 15, and we're asked to calculate the probability represented by the shaded regions. So again, when we calculate probabilities, that means we're applying the normalcdf command. So in A, we're calculating the probability that the x values are less than or equal to 118, right? Because it's shaded to the left here, we want values that are less than 118. And okay, so now let's use the calculator to calculate. So we need the normalcdf command because we're calculating probabilities, right? So the left end goes to -infinity, so we enter -1 E99. The upper bound would be 118. The mean is 100, and the standard deviation is 15. Okay, so we get 0.8849 as the probability. Okay, so that's how we use the normalcdf command, and so the other problems are similar, right? So here B, the lower bound now would be 91, and the upper bound goes to +infinity, right? So we want to calculate the probability that x is now greater than or equal to 91. So again, I use the inverse the normal CDF command. But I have to be careful now. The lower bound is 91. The upper bound is positive infinity. So in the calculator, I enter 1E99. Mean and standard deviation is still the same. And so I calculate, I get 0.7257. And then finally, the last one, the shaded region is in between two x values. So it's the probability that x is between 79 and 133. And so again, I use the normal CDF command. The lower bound will be 79. The upper bound would be 133. And then we can calculate it to get 0.9053. So these are the calculated probabilities in example 1. Okay, so now let's take a look at example 2. So in example 2, we're given the area of the shaded region. So we're given the probabilities, and we're asked to calculate the x value of the indicated point. And so here in problem 2, because we're trying to calculate x values, we have to use the inverse norm command. So in the problem A here, it's already shaded to the left, so I don't have to do anything special with the inverse norm command. I can enter it like it is, right? Because area represents the left area, right? Which in this case would be 0.9912. The mean is 100. Standard deviation is 15. And then I can just calculate it to get 135.99, but then we have round up so that it goes to 136. Okay, so that's problem A here. And then problem B, as I said before, to be able to use the inverse norm command, the area has to be to the left, right? So we need to figure out the left area, and we can do that by calculating the complement. So 1 minus 0.1587. So what is this equal to? Is 0.8413. So that's the left area. And so now I can apply the inverse norm command. So again, the number I'm putting in for the area would be 0.8413. The mean is still 100. The standard deviation is still 15. And I get, as the x value, 114.99. Again, we round up here, so this rounds up to 115.00. And then finally, in the last one, again, the area is shaded to the right, so I need the left area, which is the complement. So the complement of this would be 0.0202. And now I can calculate using the inverse norm command. So 0.0202 for the area. The mean is 100. The standard deviation is 15. So I calculated 69.26 as this x value here. And when we calculate these make sense, right? Because the mean is supposed to be 100, and so here are the x values to the right of that, right? So it makes sense that the number should be bigger. Again, here this x value is led to the right, so it should be bigger than 100, but it's closer, so not as big as 136. And then finally, this x value is far to the left, so it should be much smaller than 100. Okay, so these are some examples where we use the normal CDF and the inverse norm command to calculate things involving the normal distribution.